Marienbohr, Kirschner and Kester suggest that novices should be presented with realistic tasks, despite the fact that realistic tasks, when presented to novices, can incur severe cognitive load. They have suggested that the intrinsic aspects of cognitive load can be reduced by simple to complex sequencing, whereas the extraneous aspect can be reduced by providing substantial scaffolding of worked examples initially, followed by completion problems and then full problems. Marienbohr, Kirschner and Kester also suggest that the timing of essential information presented to students can be critical to managing cognitive load. Appropriate timing would ensure that students have the ability to construct a schema to be used throughout the task with which to integrate additional information presented at additional points in the instruction sequence. Effective web-based instruction and design takes place when content designers are also pedagogical experts. Consequently, instructional designers need several kinds of knowledge about learning across disciplines. Pedagogical content knowledge is a missing construct in instructional design and e-learning. When instructional designers are pedagogical experts but not content experts, and instructors are content experts and research experts but not pedagogical experts, the result is a bifurcation of content and pedagogy. Instructional design requires both knowledge of culture and content within each discipline, and a structural framework cognizant with pedagogical and cognitive constructs that facilitates effective instruction and learning. Knowledge of the assumptions and the beliefs that are unique to each discipline and shared by members of the discipline will enable instructional designers to gain greater awareness of the ways of knowing unique in each discipline. Good web-based instructional design may be analysed from several interfaces. According to Simmons, good web-based instruction states clear objectives and prerequisites in learner terms, has consistent layout, is learner-directed, employs a non-linear approach, is interactive, has a source of motivation for learners, provides frequent practice and immediate feedback, is concise and presents information in small chunks, and uses a variety of styles to engage different learning styles. Karnaker adds the requirement, pedagogical content knowledge. Henke focuses on the importance of web and user interface. Friesel and Hubscher suggest the building and integration of design patterns and pattern language to help scaffold web-based instruction design, especially for novice learners. A pattern language for web-based instruction based on principles for instructional design and learning theories can support the design of instructionally effective web-based courses. Education psychologists underwrite presentation aspects of web-based learning with the demands of cognitive learning behavior and strategies that enhance learning opportunities. Web-based instruction is a growth area of education and learning. In many ways there is a parallel development happening as advances in innovation in technology are providing new means of teaching and learning at the same time that educational theorists are contending with new ways of applying new educational theory to teaching and learning. To promote effective instruction, web-based instruction must be designed not only with attention to web design, interface components and opportunities, but cognizant of and in collaboration with instructional design and learning theories. The Internet and the innovative technologies that are available today provide an environment rich in resources which, if used judiciously, can empower the learner with new competencies and learning. That judicious approach requires a sound mix of cognitive psychology and instructional design strategies to ensure that web-based learning provides the right environment and instructional ingredients for effective, authentic learning outcomes.